So to begin, I'd like to introduce you to Dr. Michael Weber. He's the Deputy Director of UT's Energy Institute. He's a prolific researcher, author, award-winning teacher, and an in-demand speaker on all things energy. He is UT's go-to guy when it comes to energy. Tonight is our 110th Hot Science Cool Talks. How does time go by so fast? You know, because there are so many good people we want to hear from, we hardly ever have a speaker give more than one Hot Science Cool Talk. We keep breaking that rule for Michael Weber. Tonight marks his 5th Hot Science Cool Talk. Please help me welcome Michael Weber.
Thank you. Good evening. Thank you, Jay, for that kind introduction and President Fenves' remarks. I got to say that when I was undergraduate at UT back in the early 90s, there was this acoustic guitar player in the West Mall, always played with the Asylum Street Spankers, Guy Forsyth, who is here tonight. So it's great to be on stage with him. What an honor. I'm here to talk about energy, and the reason I want to talk about energy because energy is good. It gives us things we like, a quality of life we can appreciate. It gives us clean water, abundant food, productive industry, social mobility, physical mobility. It gives us a lot of the comforts that we appreciate, like lighting and events like this. So energy is good. We could even go so far to say energy is freedom. This is the International Space Station heading east over Asia. North is to the left and south is to the right. Everywhere there's a light. That's someone who has access to electricity. And coming up now is the Korean Peninsula, and to the right is South Korea, lit up at night, but North Korea is dark because they don't have access to it. That's autocracy. So we can even say energy is good because it gives us the freedom we want, not just the wealth and other trappings of a luxurious life. So energy is good, and we like that. But there are some concerns we have about energy. Just last decade, we're worried about running out of oil, the end of cheap oil, that kind of thing. And then in a decade, those headlines change. We're never going to run out of oil. How quickly things happen, right? And I think that's kind of funny. And of course, Texas was part of that. We led the shale revolution, shakes versus shale. So Texas was an important part of turning that story around. And sometimes we get it wrong. This was before Evan Smith's time, so we can't blame him. But the cover of Texas Monthly in 1983, so long, it was fun while it lasted. The oil's gone. 25 years later, here we are with another boom. And what does that mean for our future? Is this the way it's going to go? So we have to think about that. Well, the future might be sort of decided by clean energy and some rivalries, in particular, like the Texas and California rivalry. America's future, California versus Texas. California's sunburnt and pinched coming out of the water, and Texas is ready to go with a gasoline-powered jet ski. I like that. Headed on in. And so that's an odd couple. That's something to keep in mind. And this rivalry actually goes back a long time. Here's a statement about the old times of Texas. The difficulties of Texas are not always well understood. Texas pioneers battled bandits, dust bowls, and drought, cattle-killing freezes, falling commodity prices, bugs, and bad water, where there was water. Texans remember this, both the triumphs and defeats. They are survivors. The losers died or went to California. That's, I think, it's kind of... So the rivalry lives on in different ways. And something to think about. All right, so as we have this rivalry, as we think about the future, I just want to tell you that Texas matters, that the Texas Triangle itself is one of the nation's 10 or 12 mega regions that are shown here on the map. And the Texas Triangle is prominent. It's about 300 miles on a side, goes from San Antonio to Dallas to Houston, everything in between, I-35, I-10, I-45. And it's an important distance there because that's about the distance of one charge on an electric car or one fueling up of a natural gas vehicle or some of these alternative options. So we have a built-in test bed to try some new things. This is 80% of the Texas population, 7% of the national population, 7% of the national GDP, 10% of the energy consumption, 7% of gasoline, 10% of the CO2 emissions. We have a lot of CO2 in this triangle as well. So we have some opportunities and some challenges we need to solve. Here it is lit up at night, that Texas Triangle, Houston on the right. So this is a big opportunity, and I just want to let you know that Texas is mattering not just on a national scale, but on a global scale. We're a global scale energy producer. We're the United States' largest producer of oil, refined fuels, natural gas, lignite, a form of coal, wind, and electricity. In fact, we're the world's 3rd largest natural gas producer and the world's 6th largest wind producer, which is really incredible. So we're on a global scale what we do, and very important for refining in the United States. You can't get anywhere without a Texas drop of fuel, it seems like. The bad news is we're the world's 7th largest CO2 emitter, up there with Canada and Germany. So we're a global scale polluter, along with a global scale offerer of solutions. Something to keep in mind. Let's just look at the wind curves. This is the growth in wind capacity in China and the United States and Germany and India and Spain. And there's Texas and the United Kingdom. We're ahead of England. So we can do things at scale. Sometimes a city will go 100% renewable. We think, oh, that's cute. Let's show you what we can do here in Texas. We can put a whole country's worth of wind in one pocket of Texas. So I think that's something to keep in mind. The punchline for that is I think we can help the world decarbonize and get rich doing it. We like to get rich. We like to get rich off of our land, and this is the way we'll do it, I think. The world wants to decarbonize whether we want to or not, and they will pay handsomely for low-carbon fuels. Well, guess who's got them? We do. We have a lot of wind, solar, and natural gas, so we can help people shut down dirtier options. And so that's something to keep in mind, is that we don't have to just get rich polluting. We can also get rich cleaning things up. We also have a lot of expertise on things like carbon capture and sequestration and efficient industry. Our refineries are the most efficient in the world, for example. So a world that's moving towards decarbonization doesn't hurt us even though we're a carbon polluter. It actually just helps us, again, if we take the right attitude and take the right tack. So that we got to remember that. One more set of comments I want to make is about the Texas energy system. It's global scale, but also depends on water. And water ends up being a vulnerability for this. You're going to hear more about vulnerability tonight. This is one of the concerns about Planet Texas 2050 is how do we protect ourselves against these challenges, these natural disasters. And this energy system needs water in a variety of ways. Here's a coal plant outside of Austin, between Austin and Houston, the Fayette power plant. That's a reservoir behind it. Here's another angle of it. Look at all that water. That power plant needs water for cooling. In fact, the entire energy supply chain needs water. And if the water is not there at just the right abundance, at just the right temperature, then the whole energy system can come collapsing down. And we have examples of this from history where that's been an issue, that water can be available just in too much abundance or too much scarcity, if that makes sense, to really cause problems. And so that showed up again with Hurricane Harvey. Here's a map of the rain. Harvey dumped 34 trillion gallons of water. Let's put some numbers on that. Water is worth like $4 per 1,000 gallons. That means $136 billion of water fell out of the sky and did about $136 billion of damage, right? So this is, I don't know how to do that. It's like nature said, hey, what if we gave you a bunch of gold and we'll drop it from the sky? We're like, that's a great idea, but you got to catch it, and you got to, it's going to hit your roof and hit your head. So we didn't catch it. It went on through and did a lot of damage. That's a challenge. It also did some hobbling for the fuel sector. A lot of refineries were shut in. This was a weird hurricane for us. We're used to wind events, not rain events, and so the flooding was a problem, not the wind. So crude oil production kept on going, but the refinery shut down. So we had a gasoline problem, not a crude oil problem. So that was interesting. It also wiped out a lot of cars. Here's just one photo of one of the 3 places that store the cars. 500,000 cars were destroyed in the single largest incident of automobile destruction in the entire history of humankind, which is really incredible. Look at all those cars. Here's a picture of another depot outside Columbus, Texas, and here is some video we took of this to show that this is just one of the 3 storage places. And the thing for us to take from that is an opportunity. Let's not replace all 500,000 cars with 500,000 cars. Maybe let's just replace 400,000 of them and try mobility services, point-to-point microtransit, you name it. There's something else we could do that'd be a little bit better. We don't have to repeat the mistakes of the past, and that will give us some more resilience. It'll get people to work sooner and faster and help the economic recovery. So we got to use these challenges, these opportunities to try something new. And if we're going to do that, we got to get smarter. Energy and water literacy requires STEM education. That goes hand in hand. But STEM education is not enough. We also have to have art, because the earth without art is just, right? So you gotta, we need creative thinkers. We need musicians and fine artists in this as well. And energy industry comes to me and says, we need more than just engineers. We love our engineers. We need creative thinkers. That's going to be in a different part of campus. And so STEM education needs to evolve to STEAM education. I think we'll hear more about that tonight. Thank you very much.